Hey everybody, this is Titan 1M. Going to go over the feeds and speeds. I'm going to start with the setup folder, work coordinate system, top center. Stock is going to be 4.1 by 2 by 1 with an offset from the top in the Z direction 30 thousandths. This allows our shell mill to do a little skim layer right on the top and allow for plenty of material on the bottom for our Mighty Bite Talon grips. Post process is going to be your program number with the program comment, and we're going to use 1 for our work coordinate system offset. First operation, facing 3500 RPM, 80 inches a minute. You're going to turn the coolant to disabled, lead in, lead out 60 inches a minute, ramp and plunge 20. Geometry, nothing there. Heights, default values are fine. Passes, pass extension 1.25 inches. Linking, all of those are fine. Next operation is going to be a 2D adaptive around the outside of the part. 6000 RPM, 126 inches a minute for a 7 thou feed per tooth. Lead in, lead out 100 inches a minute, ramp and plunge 30 for a feed per rev 5 thousandths. Geometry is the bottom outside edge. Heights, we're going to go model top 0.4, model top 0.2, model top 0. The bottom height is going to be our selected contours, negative 10 thousandths. It's going to put our end mill a little bit below our actual modeled part. Passes, 4 thousandths tolerance, 0.1 optimal load. Stock to leave is going to be 15 thou radial stock to leave. Linking, everything on this screen should be fine as default because we're entering from the outside of the stock. Next operation is a 2D contour for a finish pass, 6000 RPM, 54 inches a minute, resulting in a 3 thou feed per tooth. Lead in feed rate 30, lead out 30, ramp feed rate 20, plunge 20. Flood coolant on, of course. Geometry, bottom outside edge. Same as before, model top 0.4. Model top 0.2, model top 0.1, model top 0 for the top height. Bottom height is going to be based off of the model bottom or the contour selection, same thing, and go negative 5 thousandths. Passes, you're going to change compensation type to in control for cutter comp. So in control, it's going to have a finished feed rate of 54 inches a minute. That should be fine as is. Linking, everything on here should be fine with our default values. Might want to change the 45 lead in sweep angle from 90 to 45. And an entry point of right here, so we're starting in this front left corner. Click OK. Next operation is a 2D adaptive with our 3/8 end mill. Flood coolant on. 6000 RPM, 126 inches a minute, resulting in 7 thou feet per tooth. Lead in, lead out 100 inches a minute, and our ramp and plunge 30 inches a minute. Geometry, this bottom area and this bottom area. Heights, model top 0.4, model top 0.2, model top 0, selected contours 0. The default values will also work. Passes, 4 thousandths tolerance, optimal load 0.1, minimum cutting radius 0.02, stock to leave 15 thou axial and radial. Linking, full retraction, most of these are going to be fine. Stay down level 70%, in on engagement feed rate 200. Helical ramp entry, 6 degrees for the angle and taper. Next, you'll have a 2D pocket, 6,000 RPM with the same 3/8 flat ml flood coolant. Going to go 54 inches a minute for 3,000 feet per tooth. Lead in 40, lead out 40, ramp 30, plunge 18. Bottom selections of the pocket, heights, standard, passes. The AM class you want to have no stock to leave. The PM class you want to leave a 6 thou radial stock to leave. So we're going to come back later and clean up the walls. Linking. Make sure it's plunge. Click OK. The next operation is only for the PM class. It's going to be a 2D contour, 6,000 RPM, 3,000 feet per tooth, 54 inches a minute, plunge at 20, flood coolant. Geometry is going to be these two chains. Heights, that's fine. Passes, cutter compensation is going to be in control. Finish feed rate 54 inches a minute. Stock to leave is going to be 1 thou axial stock to leave to keep the end mill off the bottom of this floor as it's cutting the wall. Linking, this should be fine with the default values. Maybe 45 degrees. Doesn't matter that much. Next operation, spot drilling. 1/4 inch 90-degree spot drill, 1500 RPM, plunging at 20 inches a minute, and we can actually disable our flood coolant on that. We don't really need it. So 1500 RPM, 20 inches a minute for the spot drill. Geometry is going to be your 7 selected hole faces. Heights, going to be model top 0.4, model top 0.2, model top 0.2, model top 0 for the top height, and the bottom height is going to be from model top offset negative 0.103. Cycle is going to be drilling rapid out. Drilling operation with the 0.177 drill is going to be flood coolant, 3,000 RPM, 30 inches a minute for our plunge. Retract 40 inches a minute. Geometry, the hole faces, optimized order. Heights, clearance height, model top 0.4, retract height, model top 0.2. Feed height, model top 0.2. Top height is going to be the model of the top. Model top. Bottom height is going to be from hole bottom offset negative 50 thousandths. Check drill tip through bottom. Cycle is going to be deep drilling full retract. Peck depth 200 thousandths and the minimum peck depth 200 thousandths. Click OK. Next operation, rigid tapping with the 1032 form tap, flood coolant, 1,000 RPM. 1,000 RPM. Excuse me. Geometry is going to be the 7 hole faces just like before. Height is going to be all the same. Model top, model top, model top. 4, 2, 2. The top height is going to be measured from the top of the hole. And the bottom height is going to be measured from the top of the hole again and go negative 400 thousandths. Negative 0.4. The cycle type is going to be tapping. Click OK. Final operation for setup 1 is going to be a chamfer. We're going to chamfer with flood coolant on with a 1/4 inch 45 degree chamfer mill. 4,000 RPM, 64 inches a minute, plunging at 20 inches a minute. Geometry is going to be our selected chains. Make sure the arrows are on the correct side. Height's going to be the standard for that. Passes. We're going to change our chamfer width to 0.01, chamfer tip offset 0.07, chamfer clearance 5 thousandths. Now make sure we get right in here without colliding with our part. Linking, everything on this should be fine as is. Run your simulation, simulate, turn off your model visibility, turn on your stock, should look for tail toolpath. Skimming that first layer, 2D adaptive around the outside, finish pass around the outside. You can go to the input tab and you actually see the cutting feed rates. There's our adaptive, our pocket, finishing. Finishing the walls. Spot drill. Tap. And make sure you switch your stock to transparent so you can actually see that we have plenty of clearance for the tap. The drill needs to go deeper than the tap. And finishing with our 2D chamfer. Good idea to have stop on collisions. There shouldn't be any collisions with this part, especially if we have enough stick out right here with this 1/4 inch chamfer tool. That's the only spot where there would be a potential opportunity for a collision. Click close, turn your model back on. Remember to save your work. And once you have created your setup sheet, as of right now for the standard mini mill, you're going to have your tool library with tool 1 being the shell mill, tool 2 3/8 flat end mill, tool 3 1/4 inch 90-degree spot drill, tool 4 is the 177 drill, tool 5 is the form tap, tool 9 is the 45-degree 1/4 inch chamfer. To renumber your tools, simply right click on a tool, renumber tools, and then change this number. Right now it's 9. I'm going to change it to 99. Click OK. Let me go back and renumber that tool. 9 to 9. The Super Mini Mill has different tool numbers, same tool, just different numbers. Just check and make sure you have the right tools for the right mill. Once you've completed your setup sheet and have had independent CAM verification by 2 other students, you're going to post-process. Make sure you post-process your entire setup. You're going to select the installed post library. You're going to go to the Haas pre-NGC, Haas pre-next generation control. For the standard mini mill, same stuff right here. Down here, scroll down and turn on G187. So yes for G187. That will allow for a little smoother, faster roughing options. For the Super Mini Mill, you're going to have to find a different next generation controller. So we go setup. We need to go to the HSM post library. Oh, that's rude. This might have to be done at school in a separate video where you download the next generation post processor. Let me go here. This website's safe. So we're going to type in HOS. And here's all the post processors for HOS. We want HOS mill. That's for the 5. So that's the pre-next generation. Tune A-axis. HOS next generation control. We want this one. You're going to download the HOS next generation control. It's going to go into your downloads folder. You then need to go into your assets. CAN posts and upload select file, downloads, HOS next generation .cps, open, upload, close, and now we can post process with my cloud post. It should be HOS next generation control. The generic HOS is for the regular mini mill. The next gen control is for the super mini mill. But I need to do the generic one. Post. Save this on my desktop. You'll save it on your flash drive. You shouldn't see this window. It's the first time I post-processed on this computer. And we now have our program with our G-code. We're going to do a quick little verification that we have our right tool numbers. Tool 1, face mill. Tool 2, flat end mill, 3/8 diameter. Tool 3, 1/4 inch spot drill. Tool 4, 177 drill. Tool 5, right hand tap. Tool 9, 45-degree chamfer mill. If you have your wrong tool numbers, you will crash. And then we have our operations. Operation 1, facing, adaptive outside, and this goes on 2D contour. And we can just scroll through all of this. Click close. We right click on setup 1. Machining time is going to be approximately 4 minutes 47 seconds depending on how long the tool changes are and our rapid feed rate of the inches per minute. You're ready to machine Titan 1M. Boom!